There's an echo here. Let me see if I can get rid of that. Okay. Hello, everybody. Um, this is the next video, and it's going to be about the Cenozoic era, Chapter 16. First thing you should know, and you got to remember the difference between the different eras. The Paleozoic era, 542 million years ago to 245 million years ago. The Mesozoic era, the age of the dinosaurs, 245 million years ago to 65 million years ago. The Cenozoic era, 65 million years ago till today. We're living in the Cenozoic era. Those are the three eras of the Phanerozoic eon, which goes from 542 million years ago till now. The periods of the Paleozoic begin with the Cambrian, then the Ordovician, then the Silurian, then the Devonian, then the Mississippian, then the Pennsylvanian, then the Permian. Periods of the Mesozoic: Triassic first, then Jurassic, then Cretaceous. Cenozoic, Tertiary, and Quaternary. Last time we talked about the Alps in southern Europe. You should know they were formed during the Cenozoic era. You should know that the Himalayas, some people pronounce it the Himalayas, formed during the Cenozoic 10 million years ago. The Himalayas are the youngest mountain range in the world and are formed from the collision between India and Eurasia. We should know that all of the mountain building activity, as you can see here in this map, all of these areas here were added onto the western margin or the western edge of North America during the Cenozoic. California, Nevada, much of Alaska, much of this part of Mexico, all the way to the west. All of this was added to the western edge of North America, and it's always added in the same way, through subduction. When subduction occurs, you get new mountain ranges. That's what this picture is trying to show you. Subduction produces mountains. So during the Cenozoic and the Mesozoic era, for that matter, subduction occurred off the west coast of North America, adding new land to the western margins of North America through mountain building. The mountain building on the east coast occurred during the Paleozoic and formed the Appalachians, which were much older mountains. Here you can see that the Cordilleran, that means west coast North America, west coast South America, there was subduction occurring off of our west coast, and you had all of these volcanic rocks in the orange and purple and yellow that were added on because of this subduction that was occurring off of the west coast of North America. That's where the volcanic activity occurred, especially in this area called the Pacific Northwest. We have a huge amount of volcanic rock, mostly basalt, that formed due to subduction occurring off the west coast of North America, the northwest United States, and also the small bit here of Canada, which is British Columbia province. Here you can see lots and lots of these volcanic deposits in Washington State, in Idaho. These are all Cenozoic in age from the subduction that was occurring off the west coast of North America. More of that. Oregon, even going down as far south as northern Arizona, lots of volcanic rocks formed from subduction are occurring off the west coast of North America during the Cenozoic era. Another thing you should remember is that we have this mountain range in our Pacific Northwest called the Cascade Mountains. The Cascade Mountains you might or you might not be aware of. Let's take a look at the Cascades. Don't forget, please, that they are Cenozoic in age. They're very young. And we'll take a look here. Here you can see that the Cascade Mountains go all the way into northern California, as far south as Lassen Peak to Mount Shasta, and they go all the way north through Oregon and Washington and into British Columbia. One of these erupted back in 1980, Mount St. Helens, and it's still active. Mount Rainier is another one that's potentially active, and it's located not too far from Seattle or Tacoma. We have Mount Hood over here, not too far from Portland. These are all, and then you have go all the way into British Columbia here in Canada. This mountain range, the Cascade Mountains, is formed from subduction off of the coast of Washington, Oregon, and British Columbia and Northern California. And the Cascade Mountains are very young. They're still growing. That's why we're still worried about Mount St. Helens erupting again, Mount Rainier, Mount Hood, and Mount Garibaldi near Vancouver. Just make a list here, ladies and gentlemen. It's not too hard. Take a piece of paper and write down everything that occurred during the Cenozoic era, everything that occurred during the Mesozoic era, and everything that occurred during the Paleozoic era, and you will know. You'll be ready, because it's historical geology. You got to know when things happen. What era did they occur in? Era, not period. But you still need to know the periods too, which we mentioned before. We also have mountain ranges that formed in the great state of Nevada. I used to live in Nevada, and this is called the Basin and Range Province in Nevada. And these mountains were also Cenozoic in age. So don't forget the Basin and Range Province. Here you can see Nevada. And this is what Nevada looks like. Look how tall these mountains are in the Sierra Nevada. Sierra Nevada mountains are part of the Basin and Range Province. They were formed during the Cenozoic from subduction off the west coast of North America. Another place out west, and if you've never been west of the Mississippi River, it's going to blow your mind when you first go. I remember when I growing up in New Jersey and then going to college in Pennsylvania, I had never been out west. And when I took field geology at Penn State, about 25 of us took a van, and we went on a trip out west to Idaho, Nevada, Montana, Utah. It was so exciting, because here back east we can see maybe some rocks exposed at the side of the road, and you'd have to maybe travel another couple miles and you see another sequence of sedimentary rocks. But out west, everything is open to the naked eye, and you have, instead of having these ancient mountains like we have back east, the Appalachians, which are rounded and eroded and worn down, we have mountains that stand tall, beautiful mountains as far as the eye can see, like the Grand Canyon area, which is in the Colorado Plateau. This whole area in Colorado is way above sea level, thousands of feet above sea level. For example, when it's hard to acclimate when you go out west. That's why the Denver Broncos always have an advantage. When other football teams go to Mile High Stadium, there's a difference in air pressure, and it's difficult for many people to breathe. It's always given the Broncos an advantage. This tall area here in Colorado, going all the way to Utah, Arizona, New Mexico, is called the Colorado Plateau. Why is it so high above sea level? Ladies and gentlemen, it's because of that subduction that was occurring off the west coast of North America during the Cenozoic era. You should know the Colorado Plateau was formed during the Cenozoic era, including the Grand Canyon. Let's take a look here and why we have the Cascade Mountains and the Basin and Range Province and the Colorado Plateau, all these things that were formed during the Cenozoic era. Well, this map shows it all. It's here you can see a map of the west coast of North America 40 million years ago, 20 million years ago, and today. When you see these black lines with triangles, that means a subduction zone. When you see two arrows moving apart from one another, like you see here, that's a divergent plate boundary where the plates are moving apart. Here you can see, and this stupid message about Prince Philip. I'm nothing against Prince Philip. I'm sorry he passed. But here you can see that in this case, the Farallon plate, which is over here to the east, is moving away from the Pacific plate at this divergent plate boundary. Now, so 40 million years ago, the Farallon plate was subducting off of the west coast of North America. And that produced a lot of those volcanoes that we talked about, especially in the Pacific Northwest, where you had the Columbia Plateau basalts, which were formed in the Pacific Northwest. And we also produced a lot of those other features that we talked about as well, the Basin Range, Colorado Plateau. But what has changed between 40 and 20 million years ago? Well, here you can see that this divergent plate boundary has moved closer to the coastline. And so now we go now, you can see that it's moved even closer. So this little plate here off the Pacific Northwest is all that remains of the old Farallon plate, and here you got the Pacific plate over here. So this little plate here is still subducting. It's oceanic plate, it's basalt, and it's still subducting off of our Pacific Northwest. That's why the Cascade Mountains are still active, because the Juan de Fuca plate, this little piece of plate here, is still subducting off of the Pacific Northwest. All that remains of the Farallon plate down here is the Cocos plate down here, which is subducting off of the west coast of southwest Mexico going to Central America. That's why you still have volcanoes in that part of Mexico going all the way down to Costa Rica, because of the subduction. Here you can see the subduction zones used to be over the entire west coast, but now they're only here and here. So between Los Angeles and San Francisco, you don't have a subduction zone anymore. Instead, you have a transform plate boundary called the San Andreas Fault. That's the tectonic situation of our west coast. Another thing that you want to write down on your list that formed during the Cenozoic era is all of these sedimentary rocks in the Gulf Coast area, especially all Florida, going all the way up to Jersey, here the southeastern Texas, Louisiana. These were all added onto the southeastern margin of North America, not through subduction. Subduction did not occur on here on the East Coast or the Gulf Coast. It's from sedimentary limestones that were deposited here in the shallow marine warm, shallow, clear, sunlit waters, because we have corals here, and they phylum Cynidria, and so we know that this was underneath the ocean, and we hit deposition off the southeast coast of North America in the Gulf Coast area during the Cenozoic era. Okay, that's it for chapter 16, and we'll do more in the next video.